Welcome back to Ava's Ops Academy. In our previous video, we explored something every manufacturing leader eventually asks. Should I rely on rule-based CV like OpenCV, or jump to deep learning models like YOLO? Today, we're going deeper. In this follow-up tutorial, we won't just compare. We will build a complete, working hybrid inspection pipeline. A simulated product on a conveyor. A label that is perfectly aligned. A label that is misaligned. An OpenCV-only inspection. A YOLO-style detection, simulated for speed. And finally, the hybrid method, YOLO to detect, OpenCV to measure. Exactly what modern factories deploy. We start with the three libraries we need. OpenCV for image operations, NumPy for array math, and Matplotlib for displaying our results nicely. Here we create an 800x400 image filled with white. Think of this as your overhead or side view camera frame from the production line. This rectangle simulates a product, a pouch, a box, a bottle panel, anything that carries a label. Light gray makes it look visually distinct from the background. This is our first label. Perfectly horizontal, perfectly placed. A real vision system should pass this without doubt. We draw a black rectangle and stamp, batch 123, onto it. The second label is tricky. Instead of drawing it straight, we first draw it on a separate patch. Why? Because we want to rotate it cleanly. This rotates the label by 18 degrees, simulating misplacement on the production line. Exactly the kind of problem YOLO plus OpenCV hybrid models are built for. We compute the top left coordinates and paste the rotated patch onto the product. Now our synthetic product has one perfect label, one misaligned label, exactly what we need. Factories never have perfect lighting, so we darken the right side slightly using a gradient. This ensures our algorithms face realistic stress, bright zones, dim zones, text contrast variation. This convert image to grayscale. We threshold the image using a local Gaussian window. This handles our lighting gradient and isolates the black labels. Contours are simply blobs. We'll filter these blobs by area and shape. OpenCV makes its decision. OpenCV uses three rules. 1. Size rule, area between 1000 and 20,000. 2. Aspect ratio, looks like a label. 3. Position rule, must fall inside an expected X-band. Great for fixed production layouts. But once labels rotate or distort, OpenCV quickly loses confidence. That's what the next step shows. Simulated YOLO detections. Instead of running a real YOLO model here, we simulate YOLO's output using the bounding boxes we already know. These look like typical YOLO results. X1, Y1, X2, Y2. Confidence. Class name. YOLO does one thing exceptionally well. It tells you where the object is, even if it's rotated, noisy, or half visible. But YOLO does not measure geometric alignment by itself. That's where OpenCV re-enters the scene. Now let's combine both worlds. YOLO gives the coordinates. We extract the exact label region. This reduces noise and focuses OpenCV exactly where it must analyze. Canny edge detection highlights text strokes and the label boundary. Then we find line segments using Huff transform. Huff lines P gives us straight line segments. If the label is straight, these lines cluster around 0 degrees. If it's rotated, we get strong lines at plus or minus 15 degrees, plus or minus 20 degrees, etc. We compute the slope of each line segment, convert it to degrees, and then average all angles for a stable reading. If the label tilt is within plus or minus 6 degrees, we pass. Otherwise, the label is misaligned. Real production tolerance might be plus or minus 3 degrees, plus or minus 5 degrees, or plus or minus 10 degrees depending on the product. Display final hybrid results. Red box equals hybrid inspection. Text shows both the decision and the measured angle. This is your final production decision. Show all four results side by side. Here's the entire story on one screen. 1. Original image. 2. OpenCV only detection. 3. YOLO-like detection. 4. Hybrid YOLO plus OpenCV alignment measurement. This is the workflow that modern factories actually deploy. With that, we've successfully debunked the entire code pipeline. You now have a synthetic conveyor simulation, a good label plus misaligned label, OpenCV contour-based inspection, YOLO-style detection, a powerful hybrid algorithm that both detects and measures full pass, misaligned logic with angle output. In the next episode, we'll take this entire system and turn it into a deployable microservice, something your PLC, SCADA, or MES can talk to in real time. If you enjoyed this deep dive, follow and subscribe Ava's Ops Academy, and comment below for sample code. Share this with someone building vision inspection systems.